Are independent and dependent variables in math the same as the variables in science? For example, in the following scenario, Deanna babysits for several hours after school. How much money does she earn? How do you identify which variable is independent and which variable is dependent? In this lesson, you will learn how to identify independent and dependent variables by examining real-world scenarios. Let's review. A variable is a number or quantity that represents different values in different situations. Examples of variables are symbols like stars or letters like Y. Let's look at the two different types of variables, an independent variable and a dependent variable. An independent variable will change by taking on different values. It's generally referred to as the x value. A dependent variable is affected by the independent variable and changes only in response to the independent variable. It is generally referred to as the y value. Both variables can change in value and can be represented by any letter like S, C, or H. Let's look at a real-world scenario so we can identify the variables. In order to earn some spending money, Deanna babysits for several hours after school. How much money does she earn? If we look at this scenario, we see that Deanna babysits for a certain number of hours, and we want to know the amount of money she earns. Therefore, the two variables in this scenario are the number of hours Deanna works and the amount of money Deanna earns. We can represent each variable with a letter or symbol. H can be the number of hours she works, and M can be the amount of money she earns. Let's take another look at the two variables. How do we know which variable is independent and which variable is dependent? In this scenario, which must happen for the other to occur? This will tell us which is the independent variable and which is the dependent variable. Deanna must first babysit a certain number of hours in order to know how many hours she will be paid for. So if she's paid $5 per hour, when Deanna works 1 hour, she will earn $5. If Deanna works 2 hours, she will earn another $5. This means that the amount of money Deanna is paid depends on the number of hours she worked, or the more hours she works, the more money she earns. So the amount of hours is independent, and the amount of money earned is dependent. It's a common misunderstanding to think that the change in the dependent variable affects the change in the independent variable. If we think about the previous example of Deanna earning money for each hour she works, we can understand this relationship better. Is it true that the amount of money Deanna earns can influence the amount of hours she works? If this is correct, this means she earns money before she works. It's not possible to know how much to pay her if we don't know how many hours she worked. In order to pay her correctly, she needs to work the hours first and can then be paid for each hour. Therefore, the amount of hours she works is the independent variable, and the amount of money she is paid is the dependent variable. Remember, x is the independent variable. This is the variable that is changing. Y is the dependent variable. This is the variable affected by the change. In this lesson, you have learned how to identify independent and dependent variables by examining real-world scenarios. How do you use a function table to represent the relationship between two variables? In the following table, can you tell which is the independent variable and which is the dependent variable? Can you tell how one variable affects another? In this lesson, you will learn how to show the relationship between independent and dependent variables by analyzing a function table. Remember, a variable is a number or quantity that represents different values in different situations. Generally, the independent variable is represented by the letter x, and the dependent variable is represented by the letter y. However, Sometimes other letters are used to represent each variable, like h, n, or s. A coefficient is a number used to multiply a variable. In this example, 2m, the coefficient is 2, and the variable is m. This means I multiply the value the variable is worth by 2. So when writing an equation or determining the rule for a function table, as in this example, the variable m represents the input value. Multiplying that amount by the value of the coefficient, or 2, will determine the output value. It's important to remember, though, when working with function tables that sometimes the rule involves adding or subtracting instead of multiplying. Let's look at a real-world scenario so we can identify the variables. Emily and Greg are going hiking for several hours. How many cups of water do they need to bring with them? If we look at this scenario, we see Emily and Greg hike for a certain number of hours, and we want to know the amount of water they bring with them. The two variables are the amount of hours they hike, or h, and the amount of water they bring, or c. Here is a table modeling these two variables. How can I use the table to figure out which variable is independent and which is dependent? The left-hand column, or the input column, contains the independent value, the amount of water in cups. The right-hand column, or the output value, contains the dependent variable, or the amount of hours spent hiking. How can I use the table to figure out the relationship between these variables? If we look at the values, we can see if they bring 1 cup of water, they can hike for 2 hours. 2 cups of water, and they can hike for 4 hours. This pattern continues through the table. So for each hour they hike, they need 1/2 cup of water. This means the amount of hours they hike depends on the amount of water they bring on the hike. Another way to see the relationship between two variables is to look at an equation of the situation. An equation for this relationship is 2c equals h, c being the cups of water and h the hours hiked. We will double the c value to determine the h value. For example, if we input a value of 1 to represent 1 cup of water, we multiply that value by the coefficient 2, and the output becomes 2, or 2 hours they can hike. Another representation we can use to see the relationship between the two variables is a graph of this scenario. The cups of water are on the horizontal, or x-axis, and the number of hours they hike on the vertical, or y-axis. This graph shows the same relationship between both variables. Let's input a couple values from our graph to check the equation. If we input 2 cups of water for c, 2 times 2 is 4, or hiking for 4 hours. If we input 4 for c, for 4 cups of water, our result is 8, or 8 hours of hiking. Therefore, the table, graph, and equation model our situation and show the relationship between both variables. It's a common misunderstanding to think the change in the dependent variable affects the change in the independent variable. If we think about the previous example of Emily and Greg needing water for each hour they hike, we can understand this relationship better. Is it true that the amount of hours they hike will influence the amount of water they take on their hike? If this is correct, this means that the time they hike changes the amount of water they have while on the hike. It's not possible to know how long they'll hike until they've determined the amount of water to bring. They can't drink water they don't have. Remember, the independent variable is the variable that is changing, and the dependent variable is the variable affected by the change. In this lesson, you have learned how to show the relationship between independent and dependent variables by analyzing a function table.